I will leave to my colleague Merveille to do a bit of the maître de cérémonie of the session. Thank you. Merveille,
thank you, sir. Yes, thank you, Serafine, and hello everyone, and welcome to today's webinar. So I'm Merveille Davouaché, and I'm the project manager of CODECS in EDO, and today I'll be guiding you through the sessions and introducing our speakers. So we have a great lineup of experts who will share some insights on digital ecosystems in agriculture. And our first speaker is Gianluca Brunori. So Gianluca is a full professor of food policy at the University of Pisa, and he has over 30 years of experience in agricultural economics, rural sociology, and food policy. And he's also the coordinator of CODECS, and he does a lot of research on innovation in agriculture and rural areas. Gianluca, the floor is yours.
Thank you very much, Merveille. I will be very brief as there are a lot of things to say. First of all, I would like to introduce the CODECS reflection on the present phase of digitalization, because we are in a phase in which innovation comes from the assemblage of different items, so devices, software, database, people, infrastructure, sensors. For example, we have smart tractors. So we have tractors since, let's say, 100 years, but now we have something different, because tractors are not only harvesting crops, but they are harvesting data, and this make them totally different machines from the past. But we can have smart animals that are connected with the cloud, with the databases, with infrastructures, etc. And even any object, an apple, can become what we call an augmented apple. So if we put a QR code on an apple, we can refer to a network of information. And for the consumers, this apple is totally different from, let's say, the apple as we experienced a few years ago. So we can say that digital solutions and digitalization is successful now when all components of this assemblage work, when the connection between components is good, and when users are able to use the outputs of these digital solutions. And but it is not only a problem of making the technical solutions, digital solution work, because we are also considering innovation. When innovation occurs, innovation now occurs mainly through recombination of these objects, because innovation is linked to recombination of different items. An apple can be transformed into an augmented apple if it is recombined together with a lot of other elements. And at the same time, a combination depends on the cooperation between items. So each the items should communicate with the other items, exchange data, exchange protocols, etc. And recombination is turned into value with service design and business model. So it is not sufficient that the technology works, because you have also to bring this technology at the farm level or at the advisor level. And sometimes it is delivered not as an object, but as a service. And at the same time, you need business models that create value out of these technologies. So for this reason, we have introduced the concept of digital ecosystems, and for us, digital ecosystems are really key to successful digitalization, which in the CODECS approach means digitalization plus sustainability. So they are not separate, they are not taken for granted, but the successful digitalization means digitalization that contributes to sustainable development goals. And we observe that the digital ecosystems are able to steer digitalization along pathways of development. At the same time, digital ecosystems are socio-technical and institutional systems. So they put together digital components, material components, but also social components, actors, and institutional systems. So for us, governance is a key aspect of digital ecosystems. And the effectiveness of these digital ecosystems depends on the cooperation between all the components. And so policies can support the development of conducive digital ecosystems. So this is in a nutshell what we are aiming at putting into evidence and to identify specific avenues for successful digital ecosystems. And with this, I would like to thank you.
Thank you very much, Gianluca, for sharing this CODECS vision of how you see digitalization and the bigger picture of digital ecosystems. So next we will welcome Doris Markdracht from the European Commission. She is a policy officer in DG Connect, where she focuses on EU policies and agriculture. And she also previously worked in DG Agri, where she focused on research and innovation, and more specifically on the digitalization of agriculture and rural areas, as well as policy systems. Doris, over to you.
Good morning, everyone. Can you hear me and see my screen?
Yes.
Thank you for the kind introduction, and thank you also for the invitation to this webinar. It's my pleasure to contribute to it, and particularly in a time, let's say, where digitalization is high on the agenda and pushed by the Commission to build forward to seize the opportunity in several sectors. And it's a pleasure for me to address the focal point on inclusive digitalization, which is very relevant, as Gianluca mentioned. Also, the, let's say, digital transformation process has to be sustainable in itself and not only foster sustainability as a goal. So we are driving by the vision of making Europe a global leader in AI innovation, development, and uptake. But this leadership must be accompanied by trust and security and respect for the fundamental rights and values. So values that are particularly significant also in the context of agriculture to achieve a sustainable and inclusive transformation. So let me highlight and briefly reflect on some important aspects. So what are the challenges toward effective, inclusive digital access? So I'm really factoring here calling on effective because digital access as such is not sufficient to receive, let's say, an inclusive digital transformation. We have in agriculture, connectivity, investment capacities, lack of cost effectiveness of some digital solutions hampering inclusiveness and digitalization, lack of tailored impartial digital solution accounting for the diversity of farms. So is a portfolio of applications for farmers sufficient to account for inclusiveness? Skills, trust are other factors. And I think the project CODECS reveals a lot of, let's say, aspects which have to be considered for considering, let's say, achieving inclusiveness in digitalization. So if we now looked from a policy perspective, what are the initiatives supporting inclusive digitalization? And there's not one-off, let's say, initiative, but we have to look at the portfolio. And I will introduce in the following some of them. We only have 10 minutes, so it's, let's say, an invitation to you to follow up and have a closer look. I will reflect on the 2030 digital decade targets. We have also the data strategy. We will not introduce it today in detail, but there's the initiative beyond under it focus and support directly and indirectly inclusive digitalization. We have the Data Act, I will reflect on it. The AI Act, you may have heard of it, entered into force the last weekend. And the AI Act is potentially an enabler for achieving trust in technologies and mitigating risk and then enhancing the trust in AI-based technologies. Then we have a number of support programs. So you are well familiar in this project with Horizon Europe. We also have Digital Europe or the Connecting Europe facility. And then particularly also important, and my colleagues from DG Agri are here as well, the digitalization strategies under the Common European Agriculture Policy, which also contribute in a tailored manner, let's say, considering the different conditions in the member states to the digitalization of the agriculture sector. If we now look at the selected digital decade objectives, it becomes quite relevant that despite it's a horizontal initiative, there are also enablers for the digitalization of the agriculture sectors. To only name some of them, the focal point on skills, on the collective resilience and bridging digital divides, and promoting the use of digital capabilities, or to develop a comprehensive and sustainable ecosystem of interoperable digital infrastructure. And I think that well links up to the points Gianluca, let's say, just highlighted. It's a connection between the different elements contributing to the digital transformation. Or more specifically, what are the targets? And I invite you to, let's say, follow later if you receive the presentations, the link on the right corner. The latest digital decade, let's say, report how the countries and at European level, what is the performance, how we progress toward the targets. But here we have the targets on connectivity, the gigabit for everyone. But we also have, let's say, targets in the field of capacity building, ICT specialists, for instance, in the different sectors, and important agriculture, more than 90% of SMEs reaching at least a basic level of digitalization and digital intensity. So I think it was very nice that Gianluca reflected on innovation. So many digital solutions can be perceived as innovation. And we have a high pace, let's say, of new upcoming solutions in the digital domain. Every day there's something new. And what we can learn from CODECS factors influencing the uptake of innovation, consider the social dimension, let me name cultural condition, legal conditions, economic parameters, and environmental conditions. We have to see the both sides, so the end users like farmers and the innovators bringing forward digital solutions. And in between, there's a need of capacity building and networking to make and bring them together and make an effective uptake of digital solutions. For agriculture, but also overall nowadays, as data-based solutions are the main vehicle. So AI-based solutions is not only the hardware devices, but the software. The importance of data is, let's say, increasing steadily to boost the digital transformation. And if you look at agriculture, I will not go into detail, but if we look at the challenges for data sharing in the value chain, we have to highlight and acknowledge a lack of trust, a limited number of actors with sufficient data for efficient AI applications, and a limited number of providers of decision-making support tools. So just some of them. And how can we overcome those, let's say, challenges? I would like to call your attention to the development of a common European agriculture data space. So the data space has, let's say, many advantages and potentials for the farmers, for the agri-value chain. But let me only highlight one aspect in the context of this webinar. So potential to make data available for innovators and other interested parties, let's say like farm advisors, intermediaries, startups, SMEs, to, let's say, capitalize the data and then, for instance, through AI and bring benefits for the farming community. Here, for instance, a richer portfolio of farm management information system approaches, and then they subsequently also reduce the increase the cost effectiveness and reduce the cost for farmers to benefit from tailor-made digital applications. So there will be a launch of the deployment action for the Common European Agriculture Data. We expect expected in Q2 of this year. And I really invite you to dig into the functioning and become active, also potentially as participant of the Common European Agriculture Data Space. And you see here, a lot of is already ongoing in the terms of data sharing initiative across Europe, which is nice to see. And frequently you have, let's say, key players driving such a data sharing initiative, like be it cooperatives, be it research organization, bridging the different farms together and building the capacities, let's say, explaining the abstract term of a data space. What is behind it? What are the benefits for farmers? Why farmers should step into it and share their data and have the trust and confidence in data sharing initiatives. Let's recall you the attention to the Data Act, which will enter into force in September of this year. And that has also implications for the functioning, the interlinks between the different actors in the agriculture sector. So one important aspect addressed under the Data Act is B2B data sharing. So meaning the farmer shares data with the manufacturers, with other companies, let's say company to company, business to business. And here, what is one important aspect, we cannot discuss the Data Act in detail. But considering that it will already enter into force in September, which may appear in far future, no, we need to build capacities that everyone, let's say in the ecosystem, has the capacities to understand the implications of the Data Act, because there will be new contract to be signed for the B2B data sharing relations. And what the Data Act, let's say, tries to empower everyone to negotiate such contracts, not to take the data sharing contracts from, let's say, for instance, manufacturers and take them as they are, but it is essential to empower everyone to look at the contracts and have the possibility to negotiate it. And the Data Act, let's say, has multiple facets, but one aspect in the Data Act is to exactly empower all the businesses to have a look whether the favorable conditions of the, let's say, data sharing context are given. And in the farming sector, that is very essential. You know that, let's say, many farmers think about they own the data, that, let's say, the Data Act is not referring to ownership, but let's say having data sovereignty, being in the control of the data, with whom do I share my data? And therefore, it's very essential that, let's say, in the agriculture sector, there is a possibility and farmers have the capacities, let's say, to sign data sharing and contracts in an informed manner. So in here, I also encourage all, let's say, actors who feel comfortable to be in a multiplier role and capacity building role to help, let's say, and enable the ecosystem to really achieve inclusiveness also in the digital transformation for this aspect. And this is only one of them among multiple. So here you see a timeline. So just to call your attention, September is coming soon, and the Data Act will enter into force. And the Data Act for the digital transformation of agriculture has many more facets. I only named one of them. Let's conclude. There is not a one-fits-all approach towards the inclusive digitalization in agriculture. So socioeconomic framing conditions have to be considered, among others, and they vary regionally. So effective digital access requires not only infrastructure, but also human capacities, trust, demonstration projects, and data, among others, you name it. So trust that multipliers like farm advisors, cooperatives can play a key role, let's say, in avoiding digital divides. And in the development of database solutions for agriculture, we play, let's say, step-by-step an increasing role. So becoming more and more important than the hardware as such. The consideration of the farm types and impartiality to increase and achieve the trust is really an asset. And here data sharing, including through data spaces, can help and enable for reducing the cost and at the same time increase the portfolio of applications for farmers. So also for the smaller ones, for, let's say, niche production components, and then also achieve inclusiveness. And finally, policy instruments, including regulatory ones, and supporting instruments, for instance, the Data Act, the AI Act, Decade Policy Program, the Common Agriculture Policy, Digital and Horizon Europe are directly and indirectly facilitating inclusive digital access in agriculture. Thank you for your attention.
Thank you very much, Dora, for sharing this overview of the key EU policies initiatives that really support and promote digitalization and innovation in agriculture. So now let's welcome Cynthia Giannocaro from the University of Almeria. So she's the director of UAL Coxfall's Chair of Agriculture, Cooperative Studies and Sustainable Development. And her work focuses on sustainability in food and agricultural systems. And so Cynthia is also a partner in the CODECS project, and today she will present the findings from a report on the analysis of digital ecosystems. Please, Cynthia, the floor is yours.
Thank you very much. I'm here with my colleague Lucas Olmedo también, or as well, and this is a work in progress, but we thought we'd talk about how we're doing things and initial results. So in CODECS, we have a work package which is dedicated to the analysis of digital ecosystems. And our first task is to map these digital ecosystems of living labs. So there's quite a few living labs in CODECS. There's 19 across a broad range of European contexts, sectors, sizes, etc. So let's start off first with talking a little bit about how we see what a digital ecosystem is. So first of all, we think of it as a dynamic system. And as Gianluca and others were mentioning, there's a lot of components that coordinate with each other. So we have digital, socioeconomic, organizational, because we have to remember that a lot of farms and agriculture are also enterprise. Knowledge, physical components. So we have the digital resources and non-digital resources. And all of this converges to support the production, storage, communication, and utilization of digital technologies, but also of digital data that comes from this digital transformation. So when we want to analyze these, we want to talk about the ecosystems and understanding sustainable digitalization. So in the past, there's been a lot of emphasis on digitalization in agriculture as if technology is the answer. And we know if we look at digitalization processes in other sectors, such as the financial sector, we can see that perhaps we're missing a little bit of sustainability in our approach to digitalization. So we want to make this concrete too at the same time. So we use a structure, and I'll talk about it in the next slide, where we're looking at socio-ecological systems, but we're grounding it in organizational approach to studying enterprise, looking at the resources and capabilities of the actors. And then there's also an analysis of AKIs. We won't get into that much here because that analysis is quite nascent and it's being done by Hohenheim in our work package. And they will present the results at a later time. So we're writing a deliverable on this, so that will be available, I guess, when it's approved. And this is where I want to focus a little bit of our attention. So I know it looks a little bit complex, but let me walk you through it. So how do we map these digital ecosystems of the living labs? Because we're dealing with very many things, and we're dealing sort of with a lot of conceptual things as well as tangible things. So our research question is, what are the critical elements for these digital ecosystems to be conducive for sustainable agriculture and agri-food systems? So how elements set these conditions, enabling and hindering resources and capabilities for sustainable digitalization. So let me explain this square. So there's been quite a lot of work recently done on the socio-ecological systems. It's a framework set out by Elinor Ostrom, in this case, McGuinness and Ostrom. She was the only woman thus far to win the Nobel Prize in Economics. And she studied her PhD thesis, actually, and a lot of her work was very much on the governance of commons. And her PhD system or research was on water systems, agricultural water systems. Okay. So when we think, and you think about water, I think it's a nice metaphor for digital, right? Because you can contain water, in a little box, right? In a pond or whatever. But water flows, and so does data, right? And unless you let it flow, it doesn't have much utility. But then you have problems thinking about the ownership. Right? So lots of nice little metaphorical things there. But let's go back to this. So we look at this framework and we notice that it has 4 corners. We have actors, so those are really important, farmers, other actors and ACEs. We have the governance system. So that's sort of like governments, but also other forms of governance. So cooperatives, for example, are private entities, but they have their own governance systems. We have resource systems, so we could think of interoperability, for example, or the wave that 5G systems, etc. And then we talk about resources, the unit, a sensor, for example. So all of these systems are surrounding our focal action situation and interacting with it, right? And then we have our social, technological, environmental, these kinds of things, these innovations. So in order to make this less abstract, right, because it's really difficult to say, well, okay, well, how do we deal with subsystems, these subsystems, and then tie it back to the focal action situation? And that's where our living labs exist, right? So we said, well, let's mix this a little bit, make it operational, use something to mediate this analysis of these 4 core systems, using something that's quite a nice body of literature in organizational studies. And this is the study of resources and capabilities. So what resources do these subsystems enable? What capabilities do they enable? That the actors at the focal action situation can have these resources and capabilities that they need to solve their problems. And we also notice that there's a relationship between resources and capabilities. If you have resources, you can sort of incubate or create capabilities. If you have capabilities, you can capture more resources, right? So it becomes sort of a virtuous circle. So we've studied these 19 living labs from this perspective, asking them, your governance system, how does it give you the resources and capabilities that you need to solve your focal action situation problem? And perhaps it hinders, right? So that's our approach in looking at how we make something that's quite conceptual, quite abstract, really concrete, something that we can really understand the true conditions of what's going on at the farm level. So this is our approach throughout the project, because as I said, this is a work in progress. So we've done this, which is in the red lines. Okay, so we've had a step 1 where we've had the living labs carried out very structured workshops, and we thank the living labs very much for what they've done, because they really took it seriously and gave us some great data. And they looked at that and they said, okay, how did these subsystems help us? Well, first they listed the resources, capabilities, collaborations, and innovations that they have. We have a classification system to help them do that, to help them brainstorm, okay? And then we look at the next question, which was, how do these 4 subsystems and the ACEs, sort of, it's not exactly a subsystem, but the ACEs aspect, enable, foster, or set the conditions for these resources, capabilities, collaborations, and innovations, okay? So basically, what does the living lab need to address the problems stated in their focal action situation? Do they have it, or are they hindered from having it due to the various subsystems that we're dealing with, okay? So the living labs then consider how these subsystems foster what they need in terms of resources and capabilities. The next step then, and this is what we're working on now, is to think about what are the specific conducive characteristics for that living lab, and we might call them indicators, for example, which is step 4, and what are the ones that are more common across all living labs. So we get a sense of another level of generalization, so that it's not just about that specific living lab, but so that we can understand the digital innovation or digital ecosystems in general, the conduciveness of them. So we're coming up with indicators that are specific and that are also more general, and we'll develop these indicators based on the subsystems and ACEs, and then we will have consultation again with the living labs and other work packages And in the end, we will come up with some sort of way to have indicators for what are conducive digital ecosystems, but also another step after this and another task will be to do a comparative analysis. All right. So we can see what works and what doesn't. And then some of our interim results. Okay, so I'm just giving you 2 examples here of the Almeria Agroecology Living Lab and the Pecorino Toscano Living Lab. So we found certain misses. So this is our specific approach. Yeah. So in the focal action situation of Almeria, we were looking at the fact that there's a real lack of data interoperability and thus difficulty in managing and optimizing scarce resources in our case. Yeah. So we looked at some of the digital ecosystem enablers, and we found that, for example, cooperatives fostered a real culture of collaboration, and there was ability to generate knowledge through a series, the resource of an experimental farm. We also found that incentives and subsidies were very important to lower the economic barriers to adoption, and that ecosystem benefits from sort of a range of technological resources and innovations, such as data integration platforms, which was something that goes way back to another European project where we started to do this in Internet of Food and Farm. So this provided this sort of centralized space for data storage and analysis. Okay. So as you can see, this is a wide range of different types of enablers, yeah? From the sort of socioeconomic to the technical. The hindrances. Well, we still have limited interoperability amongst digital tools. This is something that other sectors like the electronics sector and other have figured out a little bit better than agriculture. Okay, there's still problems with rural areas, so there's still problems with limited network coverage. The costs of technology are still quite high, and this can be a barrier, particularly for smaller farms. Right, so there might be a difference here between big corporate farms and smaller farms. And that there's an absence of clear communication of the strategies, data management plans, and the consistent regulatory support. That is the opinion of the Almeria Agroecology Living Lab. When we go over to the Toscano Lab, we can see that they also have a well-established network of stakeholders with a strong collaborative environment for digitalization. They understand the value of knowledge and its exchange, and the training is considered as a key opportunity. They have strong natural resource management. So that comes with this role of environmental stewardship. So this emphasis on, well, how do we use digital tools to become more sustainable, and also the access to public funds. The hindrances were that people find the CAP rules very complex, and they find that this hinders the financial resource utilization. There's a negative public perception around that kind of farming, okay? And that there's limited cooperation amongst farmers and public entities. And that needs to be worked on. So that, again, another social governance issue. And this is repetitive here, the poor broadband connectivity. All right. So lack of sort of the basic technological infrastructure impedes data exchange and the digital tool adoption. So this is the kind of thing that we're doing with each of the living labs, and then we will find is in common across the systems. Okay, so then we've extrapolated across the system some of these things. So if we look at the resource systems, we see that there's ongoing challenges with the internet infrastructure system. We find that financial systems must become more flexible. There's lack of standardized data systems, so that affects data sharing. There's inefficient knowledge sharing, which hinders the actors' awareness of digital advancements. Still issues with data storage systems, that it's accessible, relevant, and also that there's data confidentiality to build trust. Trust is a big issue here. And that, of course, when we're talking about sustainable digitalization, that we integrate the ecological considerations into this digitalization process. If we look at governance systems, we see that digitalization in and of itself may introduce new governance dynamics. So suddenly we have a shared responsibility in data management. We have to think about the knowledge exchange and under what kind of conditions, and also the risk sharing. There's a tension between regulation that's very precise and stable But since we're dealing with technologies which change often and very dynamic, they might end up being overly strict. And this is particularly important where we're dealing with smaller players, so that we're not excluding smaller players in this process. Insufficient coordination across government levels. The accessible sources of updated legislation information is needed, and the governance of knowledge and information that's necessary to understand the rights and obligations. So who controls, who uses, who benefits, who's excluded, who's included, as well as the knowledge flows between those actors. If we go to the actors, we see that we have aging farming population, limited digital skills. We see that actors are both data providers and users, so that creates a different dynamic as well. There's an imbalance of having key actors, so we found that technology providers perhaps were not as implicated in the living labs as they should have been. Consumer awareness and demand can drive digital innovation, and that collective action, is quite important for improving the dynamics of digitalization. Finally, and we're finishing up very soon here, in the resource units, we find that traditional funding is often inadequate. So if we look at the financial resource units, that needs to be more innovative. There is a need to tailor technology, and this is something that I'd like to really underline for smaller firms. That the knowledgeable human resources are key. So there's lots of gaps in training and skills. And the access to knowledge, storage, and information, the ability to use it and benefit from it were recurring themes. So we have all this data, we have all, knowledge, but do we have the capacity, the capabilities to use it and benefit from it? So that needs work. And that sometimes has to do with business models. And that demonstration sites and that sort of thing was really, really important for the supportive scaling of digitalization. So with that, I will say thank you, because I know we have a busy schedule and we have a lot of people on our team, and I just want to give it a shout out to them. So we can see that CNR, for example, are also involved in something which is process modeling. That's very much at the local action situation. We also have Hohenheim, which is studying the digitalization, or the ACIS, the sustainable digitalization in the ACIS. And then of course the team of the University of Almeria, and Rosa, Lucas, and myself. Okay, thank you very much.
Thank you very much, Cynthia, and for breaking down this concept and for this clear and informative explanation of digital ecosystems. So now we'll move into some practical examples with some case studies from two of CODECS Living Labs. So we will welcome first Wojtek Nowak from the Czech University of Life Sciences in Prague, and he will present the findings from the Czech Living Labs. And their work focuses on precision agriculture and sensor data integration. Wojtek, please go ahead.
Okay, thank you. Good morning, everybody. I am Wojtek Nowak. I am here behind these companies and universities and participants from Czech Living Labs. Our Living Labs is oriented to automated orchard management. This Living Lab we are calling Bromil, and here is some base information about our Living Labs. Mainly, I can, for example, explain you the main problems. Main problems of our Living Labs is water management and optimization of water management of this orchard, or we are showing there something more others measuring and understanding the environmental parameters there. And we are building something like a digital twin of reality. We will see more in next slide. On this slide, you can see that our Living Labs is oriented close to the Prague. Prague is a main city of Czech Republic, and our Living Lab is so close to our base, and we can easy to making changes or measuring, we are not need to transfer so far. And next target is for our living clubs is to climate monitoring, effective irrigation management, and a lot of other things which are coming during our experiments we are doing there. And on this slide, you can see some real picture from real installation, for example, of our humidity, temperature, and soil moisture sensors. And we are measuring these parameters by IoT sensors. It's a new type of sensors which are enabling us to monitoring everything by batteries powered sensors. Our sensors can operate it for 5 years on batteries. We are using new type of wireless technologies. It is called LoRaWAN, and we are measuring on some our stations. And our stations is installed on our place on specific parameters. For example, our temperature sensors of air temperature is installed on the same high. On the data layer, for example, here you can see our platforms, data in our platforms, and we are measuring each 10 minutes about 50 parameters, for example, from our chart. And it is real time, it is IoT, and it is very useful for many type of analysis, for future, for alerting, for decision making, and it is very useful. But we must put this data in context. And we made a lot of data layers. For example, we measured some soil parameters by one times measuring by this, for example, equipment, and it able to make it some data layers. For example, here you can see some data layers. It is conductivity of soil in depth from 0 to half meter, and you can imagine that how many data layers we can measure it by some scientific equipment on the base layer, but we can measure it any additional parameters and making data analysis and collecting data by drones. For example, we are using their RGB and multispectral and thermal camera, and it enabling to make it data layers about each trees. And we can make a map of this tree that we can calculate it, how many trees is there. We can calculate their size, we can calculate their spacing, and more and more. For example, we analyze the data, and you can see that, for example, on this picture, there is some lines, and we discuss with our farmers, and they say, okay, yes, it's true, it's correct, because this tree is different type. It's helping us to be our child healthy, and it's helping to, for example, some management, and we measure that, and it is correction that our measuring is correct, because it is in reality there's different type of tree, and we are measured by by drones, and we can help it to make a decision to our farmers, for example, which trees must be changed as for new. And there is a lot of analysis about the imagery from the drones, and there is some statistics from our data sets. And we can compare, for example, ours related to, for example, land boundaries. That is important to be correct. For example, that here is a boundaries for our orchard, and we can see, for example, some small distance between the reality and official border of ours, for example, orchard. And everything what I was presented is very simple concept where we have sensors and data layers taking from the drones. Everything is moved by digital data to our data platform. And on the end, our customers or scientific or everybody can use the data as colleagues presented today before. We are making data set and it will be ready for future usage. And thank you for attend. And here is a contact for me and my colleague. I see that we don't have much more time. If you have some complex questions, you can send me to my mail.
Thank you very much, Wojtek, for sharing this example and sharing what you do in your activities. So finally, let's welcome Mario Petkowski from the AG Futura Technologies. So Mario is an experienced agronomist specializing in digital and precision agriculture. And he will present some insights from the Macedonian Living Lab. I want to remind you that after this presentation, we're going to have some moments for questions. So if you have any, don't hesitate to put them in the chat and we'll be able to address them to the speakers afterwards. Mario, the floor is yours.
Okay. Thank you very much, Marvel, and thank you for the opportunity to present our remote agricultural monitoring and advisory system, as well as our living lab in the framework of CODECS. Can you see my presentation?
Yes, we can see it.
That's great. So who are we? It is a private company that support the agricultural sector with innovative solutions in the field of digital and precision agriculture. We have 15 full-time agronomists and experts in the agricultural areas, and our expertise covers agronomy, digital agriculture, access to market, and access to finance. Regarding the Living Lab, so RAMAS is a remote agricultural monitoring and advisory system. In the framework of CODECS, it's a living lab developed by AG Futura Technologies to support decision-making in the agricultural production through advisory services based on a large amount of data obtained directly from the field, from each phase of the agricultural production. In shorter terms, we are trying to conclude everything which Professor Gianluca and Ms. Doris said, and also Cynthia saying in the solving the challenges of implementation of digital and precision technologies in agriculture, but having in mind the diversity and the diversification of the farms itself. So this living lab is located and validated in the demo farm located in the Ovce Pole Valley. So it is a grapevine production area. So we are using our system to check and prove our ability to have improvement in the agricultural production, improvement and promptness in the decision-making process, to have an increased traceability of data, to have some kind of energy efficiency in terms of spending electricity for irrigation and other processes, agri-technical processes, and as well as, of course, optimization of such processes. So our objective is to create a model for a centralized advisory system for support and improvement of agricultural production systems, to increase the communication between the farmers and advisors, to optimize the agricultural inputs and processes, to increase the effectiveness in the decision processes, to improve the farm accountancy, and to collect and categorize each of the agro-technical operation that is held on the farm during the vegetation process of the crops. So we are trying to solve a bunch of problems, but main problems are the limited agricultural professional support, deficiency of farm accountancy and agro-technical operation data, non-optimized agricultural production processes, and energy inefficiency. Regarding the focal action situation, that is the main thing for our living lab in the CODECS project. So with the help of the workshop that we already held in the framework of the CODECS project, we have found out that the main objective is to interact with diverse actors like farmers, advisors, researchers, scientists, technological innovators, policymakers, and etc., to assess and test the RAMAS platform. We already have a bunch of feedbacks from different types of stakeholders that are in our ecosystem. So we are using and implementing the platform for storing data for agro-technical operations to improve the communication and all the things that I have said in the previous slide. In our country, RAMAS works in grapevine, barley, corn, and hazelnut farming using digital technologies to provide professional support in agricultural production and improve advisors, farmers, collaboration, because we think that the most important thing for implementation of digital and precision technologies on different types of farms is to increase the support and improve the advisor farmers collaboration, because the advisors is the first contact point with each of the technologies and each of the innovations developed in the agriculture. So we are focusing on technological innovation and developing the solution that will bring optimized agricultural production to reduce the cost and enhance the productivity and sustainability. So this is more on how RAMAS works. So RAMAS is a data center that has two streams of information movement. So we have upstream and downstream. Upstream movement of the communication is collecting all the possible data that can be collected in one farm. Also collecting the opinion of the farmer, which we think is the very significant guiding how to say aspect in where should the agricultural production should go. So the upstream data goes to the data center. All the information go to the data analysis center. That is the data becomes information, and from information we are creating advisory services, advisory processes that are going to the downstreams and goes back to the farmers. So behind all of this, we have also a calibration layer that we are doing constantly, because with each data layer that we obtain, we need to calibrate the system, and also we are calibrating the agricultural production system. So RAMAS now is like a semi-functional web application that is tested in the real world, and now we need to fine-tune and improve in visibility and user experience. The core components of the Living Lab RAMAS is the RAMAS platform, implementation of PA and DA technologies, agribusiness development strategies and implementation plan, data repository and farm management, and also the most important is the decision-making support for the farmers. Here are some examples of what kind of data we provide to the farmers that are uploaded into the RAMAS system. So we have productivity maps, pH distribution, different soil maps. We also utilize the UAV technologies in order to create NDVI digital elevation model. In short terms, every kind of data that will help the agronomist and also farmers to optimize these farming processes. Why is RAMAS unique? So we have technological integration and flexibility. We are consistent. We are providing consistent and high quality expertise, because for example, if some farmer wants to employ agronomist, they will have one agronomist, but now with the help of the RAMAS system, each farmer has 4 or 5 different type of expertise in agronomy that are working together in analyzing the data and provide suitable advisory processes. So we have centralized digital infrastructure, and we are at the end we are trying to provide to the farmer an economic benefits. Other thing that I need to mention that in the Rama system we have 6 customizable programs. We have a cost-effective model, which means that having in mind the diversity of farms and the ability and disability of different types to pay for different cost of services. So we have a cost-effective model which adapts to the farm size and farm complexity. We have accessibility and scalability, and also we are offering strategic support to the farmers in developing at least their business model in a hope that we will improve these agricultural production systems. So thank you very much. This was a short presentation from me, and if you have some kind of questions, please do not hesitate to ask. Thank you very much.
Yeah, thank you very much, Mario, for this presentation and for sharing your expertise and what you do in your living lab. I hope you all found these discussions valuable. As a reminder, this webinar is part of CODECS Knowledge Accelerator, which aims to promote collaboration and knowledge sharing among multiple stakeholders who are interested in digitalization of agriculture. So we also encourage you to stay engaged by registering to the KA community, and so we will include a link in the chat so you can join. As a reminder, all the presentations, the recording, and will be shared after the webinar, and we will also work on a highlight report with the key highlights from today's discussion, which will be shared in the coming weeks.